When a ship sails eastward or westward, time adjustment is a necessity. The LMT only applies to a particular meridian on which it is based. Each meridian has different LMT.
Zone timing system has been devised to overcome this inconveniency of ship's clock frequent alterations and to provide a comparable standard time between the ship's kept time on board at sea and at places on shore. In this system, the world is divided into 24 zones of 15 degrees or 1 hour of longitude. Each is composed of 7 degrees and 1/2 on each side of the central meridian of each zone. The central meridians are equally spaced at 15 degrees, starting from the Greenwich. To indicate the hours to be added to or to be subtracted to, from the zone time or ZT to find Greenwich Mean Time or GMT. Determine the ZT from any longitude.
Divide the longitude by 15. The quotient is the zone description or ZT. If the longitude in question is before the central meridian, the quotient is the ZT, but if the longitude in question is after the central meridian, take the next whole number. Notice the difference.
In finding the LMT, all the longitude east of Greenwich has a plus sign and all longitude west of Greenwich has a minus sign. But in finding the ZT, all the longitude east of Greenwich has a minus sign and the longitude west of Greenwich has a plus sign. In finding LMT, we pretend to believe that the sun moves around the earth. While in finding the ZT we apply the principle that the sun rises at the east and sets at the west, and that the earth rotates in its own axis in westerly manner. Evident enough that when a ship is located exactly on a standard meridian, the LMT and ZT are identical in value, but if the ship be off the standard meridian, then the LMT and ZT will differ. LMT problem. Example. A ship in longitude 137 degrees 45 minutes east, clocks keeping ZT. Find the LMT at 11 hours 23 minutes ship's time. Solution. Standard meridian, which is equals to 135 degrees 00 minutes east. Subtract it to longitude, which is equals to 137 degrees 45 minutes east. The result is the DLO in time, which is equals to 2 degrees 45 minutes east, divided by 15. The result is equals to 11 minutes. ZT is equals to 11 hours 23 minutes. Added by the DLO in time, which is equals to 11 minutes. The result is the LMT, which is equals to 11 hours 34 minutes. Using the time wheel to visualize the problem and for plotting purposes. GMT problem. Example. The ZT at longitude 141 degrees 18 minutes west is 6 hours 18 minutes and 24 seconds. What is the GMT? Solution. ZT is equals to 6 hours 18 minutes and 24 seconds. Added by ZT, which is equals to 9 hours. The result is GMT, which is equals to 15 hours 18 minutes and 24 seconds. Using the time wheel to visualize the problem and for plotting purposes. ZT problem. Example. The GMT is 15 hours 18 minutes and 24 seconds. What is the ZT at longitude 141 degrees 18 minutes west? Solution. GMT is equals to 15 hours 18 minutes and 24 seconds. Subtracted by ZT, which is equals to 9 hours. The sign is plus, then why we subtract? It is because in converting GMT to ZT, we will reverse the ZT sign and, sign reversed, it will become minus. The result is the ZT, which is equals to 6 hours 18 minutes and 24 seconds. Using the time wheel to visualize the problem and for plotting purposes.
Thank you for watching. Please subscribe and click the notification bell, for you will be updated for our next upcoming video.